Give yourself about 9 to 10 minutes and solve these three practice problems. When you do these problems, make sure you do it with pencil. Go ahead, pause the video and go ahead and start the problems. Now let's go ahead and review those three problems. As you review, I want you to now use your pen and correct your mistakes as I go over these problems. Again, use your pen to correct your mistakes. So in order to solve this problem, you have to solve this first. Sine 5 pi over 4. Again, the common mistake is a lot of times the students cancel out inverse sine and sine, and they think that answer is 5 pi over 4, but that's not the case. So let's evaluate sine 5 pi over 4. Again, if you change 5 pi over 4 to a degree, you're going to get 225 degree. So where is 225? Well, that's in the third quadrant. Okay, so theta is in the third quadrant. What is the reference angle? If the theta is 225, the reference angle will be 45. Now, what is sine of, remember, we're trying to find sine of 5 pi over 4. Since the reference angle is 45 and the theta is third quadrant, sine of 45 is radical 2 over 2. But since this is in third quadrant, sine of 5 pi over 4 will be negative radical 2 over 2. Now, what is the inverse sine of negative radical 2 over 2? Again, you have to think about the restriction of inverse sine, which goes from negative pi over 2 to pi over 2, including the endpoints. So sine of what is negative radical 2 over 2? Well, you know that in order for sine to be negative, it has to be either third and fourth, but because of the restriction, we have to think about the fourth quadrant. Again, the reference angle will be 45, because sine of 45 is radical 2 over 2, but since this is negative, what's the answer? It's going to be negative pi over 4. So our final answer is negative pi over 4. Now, let's take a look at number 2. You have cosine inverse sine of negative 1/3. This thing right here represents some theta, some angle. We got to find sine of what will equal to negative 1 over 3. Again, the restriction of sine is from negative pi over 2 to pi over 2. That is a restriction. In order for sine to be negative, it has to be in the fourth quadrant because of the restriction. And the definition of sine theta will be y over r. So r is always positive, which is 3, and y is going to be negative 1. Okay, so this is the theta right here. Now, cosine of theta will be x over r. We have r. We know what r is. That's 3. But what is going to be x? Well, that's when we use a Pythagorean theorem. So it's going to be 3 squared equals x squared plus quantity negative 1 squared. And when you evaluate that, you're going to get x squared equals 8. So x is positive negative radical 8. Now, you know that positive negative radical 8 is going to be positive negative 2 radical 2. But since x has to be positive, Since x is positive in the fourth quadrant, we ignore the negative. So x is 2 radical 2. So what is our cosine theta? Cosine theta will be 2 radical 2 over 3, and this is our final answer. Let's take a look at our final problem. It's tangent inverse cosine of negative 1/3. Now this, again, this represents some theta. And the restriction on inverse cosine is from 0 to pi. So we're looking at either the first quadrant or the second quadrant. Now, cosine theta is negative 1 over 3. That's what that means. So cosine is negative in the second quadrant, and that's the theta. And x, the r is 3, x is negative 1. So now we're looking for tangent of theta. So if you look at this triangle, tangent theta is y over x. We have x, that's negative 1. What is your value of y though? Well, again, we have to use a Pythagorean theorem. So when you evaluate this, again, you're going to get y equals positive negative 2 radical 2. But in second quadrant, y is positive. So we could ignore the negative. Therefore, tangent theta is 2 radical 2 over negative 1, which is negative 2 radical 2. And that is our final answer. So I hope you corrected your mistakes with pen